Welcome to mathematics class, and now we are going to talk about triangles. So let us see what are the topics to be covered. So first we will talk about the congruence of triangles. Then we will talk about the criteria for the congruence of triangles. Then we will talk about some properties of triangles. Then we will talk about some more criteria. We will talk about some more criteria for the congruence of triangles. Then finally we will talk about the inequalities that we use in a triangle. Right? So let us start off with our first topic, congruence of triangles. So what do you mean by the term congruence? Actually, the term congruence means being equal. Congruent means being equal or exactly alike. So let's see what does this term mean. Two triangles are said to be congruent to each other when they look exactly alike and can be overlapped onto each other. Two triangles, when they look exactly alike, or you can say one can be overlapped on another, the two triangles are said to be congruent to each other. Like these two triangles, triangle ABC and triangle PQR. These two triangles do not seem to be exactly equal, right? When they are overlapped onto each other, they seem not to match. But what you can do, if you rotate the triangle PQR 180 degrees, and now if you try to overlap it on ABC, you will see that it exactly overlaps onto ABC, right? It looks exactly equal to ABC. Therefore, you can say triangle ABC is congruent to triangle PQR, because in whatever angle it may be, it can be overlapped by rotating the figure, right? The two triangles can be overlapped onto each other by some rotational adjustments. So this is the meaning of congruency. The two triangles has to be equal, or they must look alike, and they can be overlapped onto each other. And how do we write this? We can write triangle ABC congruent to triangle PQR, right? We can write triangle ABC congruent to triangle PQR. And why can we write this in this fashion? And this symbol, note it, this symbol tells us the sign of congruency. And we write ABC and PQR in this fashion because A can be overlapped on P, B can be overlapped on Q, and C can be overlapped on R. You can see B and Q are of similar nature, A and P are of similar nature, C and R are of similar nature, right? They are corresponding to each other. They can be overlapped exactly, right? They can be overlapped onto each other exactly by matching these points. So we always write the names of the triangles in this particular order. Whatever order we follow for one triangle, we have to follow the same or similar order for the next triangle. ABC congruent to PQR tells us that A can be overlapped on P, B can be overlapped on Q, C can be overlapped on R, right? Now, if I tell you draw two triangles with one side 5 centimeter, so you can draw different triangles. Two of them are here. The two triangles having a side 5 centimeter, right? Now are these two triangles congruent to each other? Are these two triangles exactly alike? They are not, right? Even if they have one side of equal length, the two triangles do not overlap onto each other. So in this topic, criteria for congruence, the criteria for congruence, we will see the minimum number of specifications in a triangle needed for two triangles to be congruent, right? The minimum criteria is required for telling two triangles are congruent. So here you can see, giving only one criteria, that only one side is equal, does not tell that two triangles must be congruent to each other. You can see there can be many triangles with the base equal, right? Now let us try two criteria. So draw two triangles with one side 5 cm and one side 6 cm. Then also you can draw many triangles, and two of them are, once again you can tell, one of the side is 5 cm and one of the side is 6 cm, and the third side can be anything. And here also base is 5 cm and one of the side is 6 cm, and then also the triangle can be anything, right? The two triangles do not seem to be alike. The two triangles are therefore not congruent. So two criteria are still not sufficient to tell that two triangles are congruent. So let's try one more criteria. Let's go for three criteria. So let us see what happens when we draw two triangles with sides 5 cm, 6 cm and 7 cm. When we specify three criteria, let us see what happens. How many triangles can we draw? And you will find out that we can draw only one triangle using these values. We can draw only one triangle using the three criteria, right? So you can see, for telling two triangles to be congruent, we need at least three criteria or three specifications, right? So to show that two triangles are congruent, we need three specifications, like either three sides or two sides and one angle, or two angles and one side, right? So let us begin with the criteria, and the first criteria is called as the SAS criteria, or side angle side criteria. Now from the name only you can get an idea of what kind of criteria will it be. If we are given two sides and the angle between them, we can tell the two triangles to be congruent. Why? Because when two sides are given as fixed length, two sides are given of fixed length, and their separation or the angle between them is fixed, obviously it fixes the third side as well, right? If the two sides are fixed and also their separation or the angle is fixed, it automatically fixes the third side. So two triangles having two sides equal and the angle between them also equal, the two triangles must be congruent to each other. So here you can see the definition is given. Two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. Then we can tell that two triangles are congruent to each other by the SAS, or side angle side criteria. So let's take an example. You can see here we have drawn two triangles back to back with a common vertex O, right? AB is a straight line, CD is also a straight line, and from the demarcations you can tell AO is equal to OB, right? Because both have single marks. CO is equal to OD, right? Because they both have double marks. And AO, angle AOD and angle BOC are also equal, right? They are vertically opposite. And here you can see, if we consider triangle AOD, we have two sides and the angle between them. And for triangle BOC, which is upwards, we have two sides given and the angle between them is also given, right? And therefore we can tell that the two triangles are congruent. Now if you still find it confusing, let me show you. Right, in this figure we have found out that triangle AOD and triangle BOC is congruent, right? Now how do we tell? Separate the two triangles. Separate the two triangles from the top and from the base. We get two triangles, right? One is BOC and the other is AOD, right? And now what you do? Flip the triangle which is given there, which is given upside down. Flip that triangle. What you will see? After flipping that triangle, are you being able to see that the two triangles are exactly alike? Because you can see this side is equal to this side is equal to this side, and the angles were equal as they were vertically opposite, right? They were initially vertically opposite. We have just taken them out separately, so the angles must also be equal, and therefore the two triangles must overlap onto each other, and thus we can say that they are congruent triangles. So I think you have understood what is the SAS criteria. Both sides are given and the angle between them must also be given. If these three conditions, side, angle and side, if these three conditions are there for both the triangles, then we can say that the two triangles are congruent. Let us solve one question based on this so that we clear our concepts. AB is a line segment and a line L is its perpendicular bisector. If a point P lies on L, show that P is equidistant from A and B. Now to solve this kind of questions in which figure is not given, we should try to draw figure from the question itself. Let us draw it step by step. It is told to us AB is a line segment, so let us draw AB first. We have drawn AB. Now line L is a perpendicular bisector, so let us draw that. We have drawn line L and we have to take a point P on that line. We have taken a point P which is lying here, right? And we have to show that this point P is equidistant from A and from B, or the distance PA must be equal to the distance PB, right, which are these two distances, right? We have to show that these two distances must be equal when it is given that the line L is perpendicular bisector, or AC is equal to BC, right? AC is equal to BC, as the line L is perpendicular bisector, right? And P is lying at some other point. So let us look at in terms of triangles now. Are you able to see the triangles ACP and triangle BCP? And now we are going to apply the rule of congruence on this, and then if the two triangles are congruent by any angle, right, if they seem to be looking alike, then all of their parts, all of their angles, all of their sides must be equal, right? And from there we can tell the two sides or the distances AP and PB are equal. So we are trying to show triangle ACP is congruent to triangle BCP. So let us start. So you can see the line L is perpendicular to AB, right? This line L is perpendicular to AB. So the angles ACP and the angle BCP both are 90 degrees, right? Because it is a perpendicular bisector, right? So now we are considering triangle ACP and triangle BCP, right? So from the two triangles we can see AC equals to BC, because the line L was a perpendicular bisector and we have taken the bisecting point as C. So AC equals BC, as L is the bisector. Angle ACP equals angle BCP, which is 90 degrees, right? From the condition that line L is a perpendicular bisector, we get that the angle which is made by that line L and AB is 90 degrees. And you can tell that for these two triangles, the side CP is common for both of them, so the common side must be equal. For triangle ACP and triangle BCP, that side CP is common for both of them, so that common side must be equal for both of them, right? If we separate them out, the side CP will still remain the same. So CP is a common side which is equal. So you can see we have got three criterias: the side AC equals BC, the angle ACP equals BCP, and one more side which is equal, CP equals CP. So sides are equal, angles are equal, and one more sides are equal. So we can say that the two triangles which are ACP and triangle BCP, just note the order in which we have written triangle ACP and triangle BCP are congruent to each other by the rule of SAS, side angle side, right? And you can see we can overlap A directly on B, C can be overlapped on itself, and P also can be overlapped on itself. Because CP was common, we are just overlapping it like this, we are just overlapping it along the side CP. So the triangles, the names of the triangles must be written in that particular fashion: ACP congruent to BCP. Now as these triangles are congruent to each other, or they are exactly alike to each other, all the sides should be equal to each other, right? All the sides of the triangles should be equal for both of them. So we can tell the side AP of this triangle must be equal to the side PB of this triangle BCP, right? AP of this triangle ACP and BP of this triangle BCP must be equal, right? Now this, what are these parts called? AP equals BP. What are these parts called? These parts are actually called corresponding parts of the congruent triangles, right? These are the corresponding parts because for both of them they look alike. So you can see we have proved that AP equals BP, or we have proved that the distance of P from both the points A and B are equal, or according to the question, P is equidistant from A and B. I think you have seen how we have used the criteria for the congruence of triangles, which is SAS, to find out whether a point given on a perpendicular bisector is equidistant from the line segment or not, right? So let's talk about our next criteria, which is ASA, or angle side angle. Let's talk about this criteria. Excuse me. So let us talk about the ASA criteria. Now this statement says two triangles are congruent if two angles and the included side of one triangle are equal to the two angles and the included side of the other angle, or we need two angles and one side. If you take one side and one angle on this side of the side you have taken and the other angle on this side of the side you have taken, this angle and this angle. If these two angles are given and this side is given, and if these three conditions are same for both the triangles, then the two triangles can be said as congruent triangles. And also you can see it in this way: if you fix one side, if you fix the length of one side, fix the angle of one, if you fix one angle on that side and the other angle on the other side, ultimately they will end up at certain point, and this point will be the same for all the cases. If the base is fixed, two angles on the base is fixed, then they will ultimately make a triangle which is unique for all kinds of cases, right? So for two triangles, if the base is equal, the corresponding angles on the bases are equal, then the two triangles must be exactly alike to each other or congruent to each other. For example, the two triangles shown here, ABC and triangle DEF, these two triangles you can directly see from the figure and tell they two are congruent, to each other. And we have written the name in a similar fashion. Triangle ABC is congruent to triangle DEF. You can see angle B is same as angle E. Angle C, which is given in double lines, is equal to angle F, which is also given in double lines. And the base BC is equal to the base EF, right? The base BC is equal to the base EF. Therefore, as BC equals EF and angle A and angle D are the angle A and angle D are formed because of the two angles on the base, so they must also be equal, and therefore these two triangles can be overlapped directly onto each other. So we have written the names according to that, ABC, and in the same order DEF, or A can be overlapped on D, B can be overlapped on E, C can be overlapped on F. Okay, so let's do one question based on the ASA criteria or angle side angle criteria. Line segment AB, from the figure you can see line segment AB is parallel to another line segment CD. CD is parallel to AB, and O is the midpoint of AD. O is the midpoint of AD, or AO must equals OD. AO must equal OD. Show that our first statement, our first question, triangle AOB, which is this triangle, must be congruent to triangle DOC. So first we have to show these two triangles are congruent to each other, and then O is also a midpoint of BC. We have to show that O must also be a midpoint of BC, or BO must be equal to OC, right? We have to show these two statements. We have to show these two statements, and the congruency should be shown in this particular order. AOB must be congruent to DOC, or A should be overlapped on D, O is overlapped on itself, and B is overlapped on C. So let us try to do it. First let us consider these two triangles, triangle AOB and triangle DOC. Let us consider these two triangles. Now angle OAB equals angle ODC. Angle OAB, which is this angle, equals angle ODC, which is this angle. And why are they equal? Because CD is parallel to AB, it is told. CD is parallel to AB, and AD, if we take as the transversal, then these two angles are alternate angles, right? These two are the alternate interior angles, right? So we have got first criteria of angle, which is this angle, angle A and angle D must be equal. And our second criteria for angle, this angle, angle AOB must equal angle DOC. And why? Because they two are vertically opposite angles, and vertically opposite angles are always equal, right? So angle AOB must equal to angle DOC, vertically opposite angles. And our third condition, which we get the condition of a side, is OA equals to OD. OA is equal to OD, right? Because it is given that O is the point which bisects the line segment AD. O is the midpoint of the line segment AD. So AO must equals OD. So we get from here the condition of one angle, one more angle, and one side. And how are they arranged? You can see we have got this angle, and this side, a base and two angles on the base. And on this side we have got this angle, and this base, right? OD as the base. So this satisfies our condition for saying that two triangles are congruent. So you can see we can tell triangle AOB is congruent to triangle DOC. Why? Because angle A was equal to angle D, so A could be overlapped on D. O was the common point, so O could be overlapped on itself, and B and C can be overlapped onto each other, right? Because A and D have been overlapped already, so B and C are left, so B and C can be overlapped onto each other, right? According to the ASA rule, angle side angle rule. Now let us do the second part. We have to show that O is also a midpoint of BC, right? And also from the congruency of triangles, you can directly say that OB equals to OC. Why? Because they two can be overlapped on each other, right? And their corresponding parts, which is OC and OB, which look alike, must be equal, right? So OB and OC must be equal, and these parts are called corresponding parts of congruent triangles, and the reason you can just state as CPCT, corresponding parts of congruent triangles, right? So OB equals OC. So till now I think you've understood how to use the rules of congruency to get the result we want, right? If two triangles are congruent to each other, each and every part of them are equal to each other, right? Each and every part are equal for both the triangles, and not all the parts are equal, only the corresponding parts or the parts which are same for both the triangles. If this side of the triangle is having some length, then of the corresponding side which is aligned in the same fashion must be of the equal length, right? So the corresponding parts are always equal, the corresponding angles are equal, the corresponding sides are equal, right? And like this you can state equality for any corresponding parts based on the congruency of the two triangles. So you can see we have found out O is the midpoint of the line segment BC, because OC was equal to OB. So let us come to the next topic, some properties of triangles, right? So let's talk about isosceles triangle first. Let's take the isosceles triangle first, because it might be the easiest case. So what is an isosceles triangle? I think you know from your earlier classes. Isosceles triangles are those which have two sides equal and one side of different length, right? If that side is also equal, we call the triangle an equilateral triangle. And here in the figure you can see AB and AC are equal, while BC has a length different from these two values. So from the triangle, from the isosceles triangle, you can always say two sides are equal, AB equals AC, and also the two base angles B and C are equal, right? The angles on the base which is of different length are equal to each other. The base angles are equal for an isosceles triangle. Or if you look at it in a different way, you can also say that the angles opposite to the equal sides are equal. Like for angle opposite to side AC is angle B, angle opposite to side AB is angle C, and these two angles which are opposite to the corresponding equal sides are always equal, right? So let's come to our first theorem, which states basically angles opposite to the equal sides of an isosceles triangle are equal. This is our first theorem, right? So let us try to prove it from the concepts which we have learned for congruency of triangles. So in this figure you can see we have taken ABC as the isosceles triangle, where AB equals AC, and I will talk about AD a bit later. So we need to prove that the base angles, which are angle B and angle C, are equal, or angle ABD equals to angle ACD. So let AD be an angle bisector of A. Let AD be an angle bisector of A, or AD is that line which divides the angle A into two equal parts. Therefore angle BAD equals to angle DAC. So let us consider two triangles, triangle ABD or this triangle, and triangle ACD, which is this triangle, triangle ABD and triangle ACD. Let us consider these two triangles. Now from the characteristics of an isosceles triangle, you can tell AB equals AC, right? Then angle BAD, this angle, is equal to angle CAD, which is this angle, right? These two angles are equal. Why? Because AD was an angle bisector. And finally we get the side AD as the common side. Therefore AD must be equal for both the triangles, right? AD is a common side. So from these three equalities, I think you can see which rule of congruency we are applying. We are applying SAS criteria, right? Side, angle, side criteria. So we can say triangle ABD is congruent to triangle ACD, right? In the same fashion in which we can overlap them. A can be overlapped on itself, B can be overlapped on C, because the sides AB was equal to side AC. So B and C look similar, they can be overlapped onto each other, and D was also the common point, so D can be overlapped on itself. Or you can tell that the triangle which is shown here can be folded evenly along the line AD, so that it can overlap onto each other. So you can tell angle ABD, which is nothing but angle B, is equal to angle ACD, which is equal to angle ACD. So we have proved by CPCT, or corresponding parts of congruent triangles, that angle B must be equal to angle C by using AD as the angle bisector, right? So we have proved one of the criterions of an isosceles triangle, one of the characteristics of an isosceles triangle, which is the base angle must be equal, right? And you can also prove the converse of this theorem, or if you are told that for an isosceles triangle the base angles are equal, then the corresponding sides will also be equal, or if the angles are equal, the sides opposite to the angles, the corresponding side opposite to the equal angles must be equal. And this theorem can be proved by the other rule, which is ASA criterion, right? It can be proved by the theorem ASA criterion. So I leave this exercise to you as an homework, and you can just try it and see that it is true that if one of the criteria is given, other criteria can be got from by using different congruency rules. Other criteria may be obtained from the given criteria by using certain congruency rules. So let us solve one question based on this. ABC is an isosceles triangle. ABC is an isosceles triangle in which the altitudes BE and CF are drawn to the equal sides AC and AB respectively. So we have got an idea that AB and AC are the equal side and BC is the base, and BE and CF are the altitudes drawn from the vertex B and C, or the angle F is 90 degree and also angle E is 90 degree, because it is told they are altitudes or the heights, and heights are always measured in a perpendicular fashion. So we have to show that these altitudes are equal. We have to show BE equals CF. These altitudes or the line for measuring height is equal for both of them. So let us begin. We are considering now two triangles which are BFC and triangle BEC. BFC, which is this triangle, right, which is this triangle BFC, and BEC is this triangle BEC, right? It is this triangle, right? So we are considering these two triangles with a common base BC. Now for these two triangles you can get the angle BFC and angle CEB as 90 degrees because they are altitudes, right? So they both must be equal, and BC is the common base, right? So for both of them the length of BC will be same. So we have got angle and the side. So if we check for the third angle, which is FBC, which is nothing but angle B, is equal to angle ECB, which is angle C, right? Or for triangle BFC we have angle B, and for triangle BEC we have angle C, and these two angles from the characteristic of an isosceles triangle are equal, right? The base angles are equal. So the angles BFC must be equal to angle ECB because it is an isosceles triangle. So I think you can see we have got an angle, a side, and one more angle, right? We have got ASA, or angle, side and angle. So you can directly state that the triangles are congruent to each other, or triangle BFC is congruent to triangle CEB, and maintain the order. BFC is congruent to triangle CEB, or B can be overlapped on C if the two triangles are separated, out, they can be overlapped onto each other in this fashion. B of the first triangle can be overlapped onto C of the second triangle, F can be overlapped on E, and C of the first triangle can be overlapped onto B of the second triangle, right? So we have written the congruency statement in this fashion, in the order in which they can overlap onto each other, and the rule which we have used is the ASA criteria. And from there you can directly say CF, which is a part of triangle BFC, is equal to BE, which is a part of triangle BEC, right? And these two are the corresponding parts of congruent triangles, right? These are corresponding parts of congruent triangles. So I think you have understood how we can find the criteria for making two triangles congruent to each other, and from there we can find what are the corresponding parts of those congruent triangles, right? And those corresponding parts must be equal to each other. So in this class we have learnt about the congruence of triangles, some of the criteria for telling that two triangles are congruent to each other, and we have learnt about some of the characteristics of isosceles triangle, right? Like the two sides are equal and the base which is different from them, the angles which are on the base are equal, right?